Hello everybody, today I will be covering normal distribution, which is a very simple concept. Essentially, we are going to start out with this curve, which is the normal distribution graph. It's not a graph, but it's the curve. And we have a mean. This is our mean. And essentially, we have standard deviations. Now, standard deviations are just the amount above and below the mean. So here our graph is split into these compartments, which are percentages. So here we have 34%, we have 13.5%, we have here 2.35%, and here we have 0.15%, right? And on the other side, it's going to be same 34%. And then we have the 13.5%. And then we have the 2.35%. And then we have the 0.15%, right? Now, essentially, what this question here is asking is, all right, one standard deviation away from the mean. So let's say one standard deviation below, which is 34. One standard deviation above, 34. See? So it's one standard deviation. So we just add these two. So this would just be, I think, 68. So that would be 68%. Now, two standard deviations away, we have to add 34 plus 13.5, which is 4, 5, 6, 6, and then that is 46.5. So 46.5, and then we plus 46.5 plus 46.5. So 46.5 times 2. And that would be, oh my god, basic caveman math. I did math, brother. This answer for this two standard deviations away is 93. So 93% would be two standard deviations away, right? And here, three standard deviations away would be 48.80, 85, and that times 2 is 97.7%. That's three standard deviations away. So 1, 2, 3, 1, 2, 3. All right. Now that we understand this is our mean, and these are our standard deviations above and below the mean, right? Now we see that, okay, the height of women in a particular community are normally distributed with a mean of 65. So instead of the 0 here I would draw 65, right? And it says standard deviation of 3 inches. So when it says that, I instantly, okay, let me just draw the 34. I instantly do like, okay, what's 3 plus 65? 5, 6, 7, 8, right? 68. And I'd keep adding that. So 68. That'll be 71, 74. Sorry, 74. Let me erase this. 74. And then so on. So I'm going to finish this and I'm going to come back. All right, I have returned. And essentially what I did here was I plussed to the more side. So I did 65, which is the mean, plus 3, 68, plus 3, 71, plus 3, 74, plus 3, 77. And then, so 65 minus 3 on the lesser side would be 62, 59, and 56, right? So it says, what percentage of women are shorter than 62 inches? 62 inches is here. So it said, what percentage are less? So to find that, it would be this entire side. So 62 less. So it'd be 13.5 plus 2.35, which is 16%. So women that are shorter than 62 inches consist of 16% of this data, because 13.5 plus 2.35 plus 0.15 is 16%, right? Now it says what percentage of women are taller than 71 inches. So here we see 71, right? 71 has the percentages 2.35 and 0.15. So 2.35 plus 0.15 equals 2.50%. So here we can see that 2.50% are taller than 71 inches. So wait up. Wait, that's 68. That's not 71. Wait up. Never mind. I am back. It is. This is correct. All right. What percentage of women between 56 inches and 74 inches tall? Right? So here we see 56. Okay. We see 2 point, what is this? Between 56. Okay, what's that? 0.15. It starts from 0.15 to 74. Now here normally I would do normal CDF because I feel like it's the easiest way to calculate this, honestly. So I just do normal CDF, which is it's just a better way of calculating all of this and adding the percentages. So you would do the lower bound, which is 56, right? And you do the upper bound, which is 74, and you do the mean, which is 65, and then you do the standard deviation, which is 3, right? And then you throw all of this into a graphing calculator under the command normal CDF, so vars second normal CDF. I'm going to do that right now. All right, I open my calculator as I see a Clash of Clans ad. Let's go to the equation. Now here I put normal CDF, I clicked on second, I clicked on vars, and then I got normal CDF, and then I pasted this in. We got our lower bound, we got our upper bound, we got our mean, we got our standard deviation. Right, now I'm going to exit out of this calculator because these ads are getting weird. Okay. Now here we got 99.7%, right? And here it says what height describes this 2.5th percentile. Now what height describes the 2.5th percentile? Now you would normally see this and be like, okay, well 2.5 would be like this, right? That would be like 74. But no, you have to show your work. So you would do inverse norm. This is the calculator command. Inverse norm, and then I think you have your 2.5. Wait, 2.5th percentile. That's a percent. So you do 0.025, and then you do dash, and then you do your mean, which is 65, and then you do standard deviation of 3. Now, if you plug this into your calculator, it'll give you this answer. As you can see, I have brought up my calculator, and it says 59.12, right? So that would be just 59%, right? So that is how you do this. Now let's go to what height describes the tallest 16%. Now for 16% it says tallest, so that means that it's the greatest. So we have our upper bound, but now we have to determine what percent it is. So normal CDF should do the trick. We got normal CDF, and then we have, this one is a little different, right? So you have your lower bound, right, which is 0.16, right? And essentially what you have to do here is just put your upper bound, which is 9999, and then you put your mean, which is 65, and then you put your standard deviation. Now you just plug this into a calculator, as I'm going to do right now. Honestly, this one I kind of messed up. I'm looking at the key right now, and going back on this, this is not correct, because this is a completely excessive way of doing this. Essentially, for this, it says what height describes the top 16, right? The tallest 16. So if we see here, we have 16%, right? So the top is 16%. We have 13.5 plus 2.35 plus 0.15, right? That's top 16%, and where it starts is 68. So that would just be the 68 inch. Wait, inch? Yes, just 68. 68 would describe the height, because it's the top 16%, which is 68. All right, on to the next example. Suppose the average score on a French quiz was 37 with a standard deviation of 7 points. Now what we do is we do our average score, which is 37, our mean, and then we put the standard deviation of 7 points. Now a standard deviation of 7 points is just 37 plus 7 and 37 minus 7. Let's do that right now. Okay, brothers. So coming back at this, we see that the question asks, describe the scores achieved by the middle 95% of students. Now, the middle 95% can be described as 68, which is here. So it's between these. So it's 68%, right? And then we have 95%, and then we have 99.7%, right? So the percentage of here, 95%, is actually between 23 and right here, 51, right? So it's between 23 and 51 scores. Approximately what percentage of students score between 30 and 37? To find this, well, it says approximately what percentage of students score between this. So we could just say 34%, because it just says 34%. Now, what percentage of students approximately score between 23 and 37? Now, 23 and 37, we see 23 here, 13.5, we see 37 here, right, which is 34. So 23. So it would be like 1, 4, 4, 5, 6, 7. So it would just be 47.5, because we added this. So 13.5 plus 34 is just 47.5. And approximately what percentage of students score between 23 and 30? That's for 23 and 30. We see here 23 and 30. Again, we see, well, 23 was 2.35. Now 2.35 plus the 13.5 is, well, 3, 4, 5, so it's 15, so 15, so it's 15.40, right? Yeah, so 15.40. And approximately what percentage of students score below 30? Below 30, we could say 13.5. This would just be 16, honestly, because 13.5 plus 2.35 plus 0.15 is 16. 16%, 15%. If there are 40 students in a French class, about how many of them scored below 23? So here we are actually given variables, like the numbers that we have to plug in. So in my professional caveman mind, I think, okay, how scored 23? I look 23. 23 below is 2.50. Yes? So I'll just add the 0.15 plus the 2.35, which I get now 2.5%. Now, 2.5% of students below 23, and if there were 40 students, So in my mind, I would just turn 2.5 into a decimal. I'll do 0.025, and then I would times that by 40 to get the number of students out of 40 who scored less than 23, which is 1. Now, the height of male students are normally distributed with a mean of 170. Instantly plotted 170. Standard deviation of 8. We're going to plot that 178, right? And then we're going to keep plotting that until this is filled up. I will be right back. All right, after fully drawing this, I'm going to look 162. We locate it, 162 here, 170 is here, right? And what's between them, right? So between 162 and 170, well, that's just 34. With that, we can go on to the next one, which is between 170 and 186. Now, let's see. 170, we got here, and 186, right? And between these, we have 34 and 13.5. Now, as we know, 3 plus 4 is 7, and 3 plus 1 is 4. So 47.5% is what we have between, and same for less than 162. What's less than 162? It is 16%. And 178, which is here, to 186, between them is just 13.5. Thank you for listening. Sorry for the long video. I hope this helped. Bye bye.